All right, good morning. Happy Monday. Let's get this set up. Okay, we're going to be doing a couple things today. First of all, I'm going to be talking about the state testing for half the class. And then in the last hour, I'm going to finish the lesson 3.4. Okay, so the first thing to do is I want to talk about the state because the whole month of April pretty much is going to be spent on the state test. Now, the only people that are taking the state test are 11th graders, okay? So we have 3 11th graders in this class, and the rest of you are 12th graders. And so I wasn't going to do this with you, but I thought, yeah, I'm going to do this just because, number one, you might see some of these problems on the final because everybody's focused on state testing. You know, the school is focused on it. The district is focused on it. Every school in California is focused on it. The state of California is focused on it. And the stands for California Assessment of Student Performance and Progress. And all 11th graders are going to be taking it. So what I've decided to do is I decided to give you guys all an assignment with just problems. So I'm going to share my screen with show you what I'm talking about. So I want to go to the classroom. I just want to make sure you understand what I want you to do. So we're going to go to period 2. This is how I see things. So there's your period 2. Let's go in there. And we're going to look at the assignments. It's called the CAASPP Practice and Training Test Directions. And I want to be able to edit this. Hold on just a second. Let me edit this. Okay. All right. So whether you're in 8th grade or 12th grade, you need to pay attention. And this part right here for 11th graders only, 12th graders, you can get a drink of water or something. All right. So these are directions for the CAASPP Smarter Balanced Assessment Test, online practice and training. There's 2 tests that I want you to look at. The high school training test, which is yellow, and I'm going to show you it, focuses on technology that's required for the actual test. So it talks about, teaching you and whatever else you need to know as far as technology is concerned. The practice test, which I'll show you, focuses on the actual math that will be encountered on the CAASPP. So for everybody in this class, what you're going to do is I have directions down here, CAASPP Practice and Training Test Directions. You're going to follow those directions, and we'll look at them in a minute to learn the required notes if necessary. You're going to take the pink practice test and show your work like an exam in class, take pictures, and submit them. Okay, now I'm time today to mess around with this, but let's take a look at these directions that I did for you. All right, so what you're going to do today during class is you're going to go to caaspp.org and you're going to click on training tests. So this is what it looks like, and it's raised in training tests. You're going to click on student interface practice and training test, which looks like this. You don't need a code or anything. You just need to make sure that these are user on, guest session on, click sign in. It looks like this. I'm just going to sign in. I don't care what you're in. You're just going to pick grade 11. Everyone's picking grade 11. And I'm explaining this again. The The pink are, and the yellow is technology. And this is what it looks like. And we're going to, and so I'm just showing you that when you go into the CAASPP, this is what it looks like. So this right here is just the math practice. Now, if you're an 11th grader, try to do the math performance task too, because the CAASPP is made of two parts. It's made of the math part, of the performance task part. Okay, but for this, you just have to learn the technology and do this math test. That's the bare minimum for everyone. All right, so pretty straightforward, hopefully. I hope that makes sense. Let me get out of here. All right, now, this is only for 11th graders. So 12th graders, just be patient. Let me just go through this with the 11th graders. If you are an 11th grader who will be taking the actual CAASPP test in April, you must write this down or take a picture of it and make sure you have the following. All right, you need a full issued Chromebook. So you cannot use your MacBook Pro. You cannot use, you cannot use Microsoft Edge browser. You have to have a Chromebook, and it has to be school issued, and you can pick it up in the Rancho bus loading zone. I read as soon as possible. Also, down below here, you're going to have your student ID number. And I showed you down here, if you click on this, you will be able to access your student ID number. What I recommend, just write it down so you have it. Just write it down so when you take the exam, you have it right at your fingertips. All right. This test ID is on testing day. The camera's on, or the testing day, and earbud phones you're going to need on the testing day. So these two things you need right away. You need a school issued Chromebook, and I showed you how to access your student ID number down here. All right, so the whole class, the 12th graders, don't worry about this student ID number. You don't need it. And don't worry about this 11th grade note. So what we're going to do now, I'm going to let you go. I'm going to let you on yellow or the pink, and on the CAASPP website, and I'm going to do while I'm here. You're going to stay in WebEx, and you're going to go through this process. You're going to follow these directions, and you're going to start on these two, the yellow and the pink, like I told you here. And this assignment, like I said, is due. I think it's April 5th that it's due. All right, does anybody have any questions? All right, well, class is over at 12:10, but we're going to come back for a lesson at 11:40. So is that right? If class is over at 12:10, is that 30 minutes? Yes, it is. So at 11:40, you're going to come back here to, and I'm going to teach the second part of lesson 3.4, which is solving logarithmic equations. Okay, the first part, you can work on this. All right, does anybody have any questions about what I want you to do? If you have any questions, I will be in WebEx for you to ask me questions. So don't hesitate to ask me any questions. Let me stop sharing my screen. Okay, there. Any questions, just go ahead and I will see you back here and ready to get the lesson at 11:40. Okay? All right, let me know if you need any help with the CAASPP website. All right? All right. Remember, you don't need that student ID. You only need that for the actual test. That student ID, you don't need this for this practice. All right, did you guys make it back? Hello?
Yeah.
Okay, so thank you. So what we just did is for everyone, whether you're in 11th or 12th grade, because this could benefit you for the final. This is an assignment that's going to be due when we come back from spring break. But if you're an 11th grader, what are two things that you have to do before spring break? So this is the week before spring break. We're not taking any more exams. We're done. What are the two things you need to do before spring break? What do you have to have? Because the whole month of April is testing. What do you have to have? Two things. You have to have a school-issued Chromebook. If you don't have it, you're not going to be able to test, number one. And number two, you have to have your SSID number, your student ID number. And I gave the directions below, the directions for the practice test to get that SSID number. So those are the two things you need this week. What are the two things? You're 11th grader?
A school Chromebook and your SSID.
Yes, thank you very much, Jaden. All right, so anybody have any questions about those practice tests or anything else? Okay, what we're gonna do now is I'm gonna finish lesson 3.4. So last week I talked about solving exponential equations, and today I'm gonna finish off solving logarithmic equations. So last week, the goal was to get the variable down from the exponent. So it's like the variable's up in the exponent, get him down. So now what's going to happen, let me just show you, is you're going to have a variable stuck in a logarithm. Don't write this down, just pay attention. So he's stuck in there and you got to get him out of there. And I'm going to write all this down, but I just want to tell you, when we solve these, let me change this to. When we solve these, any positive answer, okay, the logarithm can't be negative. So, and I'm going to be going over this, the logarithm can't be negative. So if your answer is 2, that's a good answer. If your answer is -3, that's going to be a good answer because -3 plus 9 is still positive. But so that's a good answer. But if your answer is like -11, you're going to have to throw it out because -11 plus 9 is -2. So the answer can be negative, but the logarithm cannot be negative. So in other words, you can't have a solution that makes the logarithm negative. Okay, and I'm going to go through all that, so you don't need to write that down. All right, so let's do some examples, and hopefully I'll explain this very clearly. If you have any questions, make sure you ask me. So this is the third objective. And it's using the definition.
Are these repeated notes, Ms. Birch, or are these new notes?
These are new notes. So last week I taught lesson 3.4 part 1, and this is the second part of lesson 3.4, which is solving logarithmic equations. So here's the definition of a logarithm. And you've had this before, maybe it was written a little bit different, but here it is. log base b of m equals c. The letters were different, it doesn't matter. So exponential form would be b to the c equals m. So remember back a few lessons where I asked you to take logarithmic form and write it in exponential form and write exponential form in logarithmic form? That's what we're doing. So see how the base of the logarithm is the base of the exponent? And what's inside the logarithm is what the exponent is equal to. And what the logarithm equal to is the power of the exponent. So m has to be 0. So that's why I'm telling you the logarithm can't be negative, because m has to be greater than 0. The base has to be greater than 0, and the base cannot be 1. All right, so let's solve. Okay, so the first thing that comes to mind when you see this is confusing. What do we do? It's like, we've never seen anything like this. What do we do? Solve means find the variable. And here's what you do when you say, I don't know what's going on, this is confusing. Do you see how that's written in this form, log base b of m equals c? Well, since it's written in the exact form, we can write it as an exponential equation, and guess what? We can get rid of the word log. So wouldn't this be 4 squared equals x plus 3? Because isn't the base of the logarithm the base of the exponent? Isn't whatever in the log is what the exponent's equal to? And isn't what the logarithm's equal to the power of the exponent? So see how I used the definition to get rid of the word log? So you can solve, this is linear, can't you solve it? Isn't this 16 equals x plus 3 when you subtract 3, isn't that 13? Well, is 13 a good answer? Because I just got through saying you can't have a solution that makes the logarithm negative. Now, I'm very careful about what I wrote. I did not say you can't have a negative solution. You can have a negative solution. What I'm saying is you can't have a solution that makes the logarithm negative. So isn't 13 a good answer? Because 13 plus 3 is 16. Isn't 13 a good answer? Yes or no?
Yes.
Yes, it is. Now, if we had an answer like -1 is also a good answer because -1 works. -1 plus 3 is 2. But if you have a -5, no. Because -5 plus 3 is negative. So you can't have a negative in the logarithm. Can't have a solution that makes the log negative.
Ms. Birch, so it can't be -4 either, right? Because then it'll be -1.
That's correct. You're absolutely right. Can't have, so Jerry's saying, what about -4? Well, -4 plus 3 is -1, can't have it. So he's just pointing out you couldn't have a -4 either, right? Good. All right, now I want to leave this up here. So can I erase this one? Do you guys have any questions about this one? We're going to do another one like it. So when you have a log, or if you can make one log by condensing, you're going to want to use the definition. Watch. So this seems hard, but it's really not if you understand what I'm talking about. So you really want to try to conceptually get what I'm saying here. So we're still solving. What solve mean?
You find a variable.
Right, find the variable. Now look at this. We don't care if it's a natural log. Log is log base e. We don't care. We can still use this definition. But you see that number? There's no number in front of the log. I mean, there's a 1 in front of the log. You can't have that number there. So you can't use the definition with a bunch of extra fluff. It has to look like this. So it's like, okay, well, I can divide by 3, can I? So if I divide by 3, that's a product, right? Isn't this the natural log of 2x equals 4? And doesn't it look exactly like this now? Isn't that log base e of 2x equals 4? So we're going to write it in exponential form. So how do you write it in exponential form? What's the base of the logarithm? What's the base of a natural log?
E.
Yes, good mark. It's going to be e to the 4th equals 2x, and we got rid of the log. Now just solve for x. Divide by 2. X equals e to the 4th over 2. And you don't have to multiply that out. We don't need an approximation unless they ask for it. That's a perfectly good answer. But here's the question. Does that make the logarithm negative? Is 2.7 to the 4th power divided by 2, is that going to make the logarithm negative when you multiply by 2?
No.
Absolutely not. This is a positive, whatever it is, some decimal. So this is a positive multiplied by 2 is a positive. So this is a good answer. We're just going to leave it like that. Unless they want us to approximate it, fine, but why approximate if we don't have to? So in this one, we got rid of this number in front by dividing by it so that we could put it in this form. I'm going to show you another one that's different. You all see where Mark got e, right? This is log base e. So e to the 4th equals 2x. Can you guys unmute yourself and just tell me, yeah, I see it. I see what you're saying.
Yeah, I got it.
Okay.
Got it.
Yeah. Other people?
Yeah, I got it.
Yeah. Okay.
Yeah, I got it.
Okay. Thank you. Weird stuff, but easy once you see what's going on. Confusing if you don't. So real confusing if you don't. If you see it, it's pretty simple. All right, check this one out. Log base 2 of x plus log base 2 of x minus 7 equals 3. Now, just to let you know, at the end, we're going to have to check both the logs and make sure we don't make them negative. So don't forget to check at the end. Okay, but now we can't use this. We don't have a log. So use this when you have one log, right? Use with one log. Well, look it. Can't we make this one log by condensing? So can't we change a sum to a product? So can't we write log base 2 of x times x minus 7 equals 3 by using the product property? Right? Remember condensing?
Right. Yes.
Right. So isn't this log base 2 and you multiply it out, x squared minus 7x equals 3? Distribute, right? And now look, doesn't it look like this? log base b of m equals c. So let's get rid of the log. So this is going to be 2 cubed equals x squared minus 7x. Well, isn't this a quadratic? So are we going to try to factor? So wouldn't this be 8 is equal to x squared minus 7x? And don't we want to set it equal to 0 by subtracting 8 and try to factor? We don't want to use the quadratic formula, right? You got anybody want to use the quadratic formula?
No.
No. So here we go. What multiplies to give negative 8, just guess, and adds to give negative 7? It's a puzzle. Factoring method 5.
One and eight. Oh.
Thank you. Where's the signs? Is it a negative 8 or positive 8? You have to add to get a negative. So wouldn't it be a negative 8 and a positive 1? Yes?
Yeah.
So what are your possible solutions? Then we got to check. What makes that 0?
8.
What makes that 0?
Negative 1.
All right, so here we go, guys. Can you have an 8 there?
Yes.
Okay, can you have an 8 minus 7?
Yes.
So that's a good answer. Can you have a negative 1 there?
No.
No. So you can check the other one if you want, but he already fails on the first one. So he's extraneous and has to be thrown out. Can't have a solution that makes the logarithm negative. He actually makes both of them negative. Can't have that. Okay, so this is what you do when you're solving logarithmic equations. This is what you do. You get one log. So what if you can't get one log? So what do we do if we can't get one log? Let's say I can only get 2 logs. This is the fourth objective. This is called using the one-to-one property of logarithms to solve. So do you remember that property that I gave you that I didn't know the name of it, but you could get rid of the bases of the exponents? Well, there's one for the logarithm. Look what it looks like. If you have log base b of m equal to log base b of n, guess what? If you can equate the logarithms like that, then you can get rid of the logarithm. So there was an exponential one that looked like this. So check this out. We're still solving. So in this problem, we have the natural log of x plus 2 minus the natural log of 4x plus 3. And remember what I said last week? I said you cannot touch what's in the logarithm. So you can't touch that stuff inside, only by using, properties. equals the natural log of 1 over x. And it's like, hold on a second. We have 3 logarithms? Now what? Okay, watch this. I'm going to get 2 logarithms. I'm going to use the quotient property. Watch. The quotient property says that I can make 1 log and division. So that would be x plus 2 over 4x plus 3 equal to the natural log of 1 over x. And guess what? I have this now. I have logs with the same base. So guess what? I can get rid of the logarithm. So I have x plus 2 over 4x plus 3 is equal to 1 over x. And remember, when you have 2 fractions that are equal, you can cross multiply. And it doesn't matter what side they go on. So I'm going to put the x times the quantity x plus 2 in parentheses equals 4x plus 3 times 1. And there we go. We're going to end up with a quadratic, and we're going to have to factor. So here we go. So this would be x squared plus 2x when you distribute is equal to 4x plus 3. I'm going to subtract 4x. I'm going to set it equal to 0. So this would be x squared minus 2x equals 3. And now when you subtract 3, you get x squared minus 2x minus 3 equals 0. We're going to try to factor, unless you guys want to use the quadratic formula.
No.
No, we don't. All right, so what multiplies to give a -3 and adds to give a -2? 3 and 1? And what's the signs? Come on, is it positive, 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 negative, negative, positive, negative? What is it?
The -3 and positive.
Right. Because you have to get a -2x in the middle when you FOIL, and you have to get a -3. All right, so what are your solutions possibly?
-3 and, or positive 3 and -1.
Okay, so can you have a positive 3 there? Can you have a positive 3 there?
Yes.
Can you have a positive 3 there? That would be 4 times 3 is 12 plus 3. Can you have that?
Yes.
Can you have a positive 3 there?
Yes.
Okay, what about a -1 here?
Yes.
Yes, but can you have a -1 there that gives -4 plus 3?
No.
No, so you have one solution. And that's the lesson. But I'll work another problem if you want me to. So we do have time. Do you want me to work another one like this?
Yes, please.
All right. Okay, I'm on page 489. Page 489. And let's see here. I'm going to work problem number. I'm going to work problem number 83. So you have log base 10 of x plus 4 minus log base 10 of 2. And it's equal to log base 10 of 5x plus 1. Now, I know I don't have one log, So can't you use the quotient property and use the property I just gave you on this? In other words, equate two logarithms. So if we use the quotient property, it would be log base 10 of x plus 4 over 2. Can't cancel parts of a sum or difference. And you get log base 10 of 5x plus 1. So doesn't that look like the property? And doesn't the property say if I have log base 10 of something and log base 10 of something, I can get rid of the logarithm? So wouldn't this be x plus 4 over 2 equals 5x plus 1 over 1? Yes.
Yes.
And when you have a proportion, can't you cross multiply? So wouldn't this be 2 times the quantity 5x plus 1 equals x plus 4 times 1? So wouldn't this be 10x plus 2 is equal to x plus 4? And isn't this just linear? It's not a quadratic, which is good. So couldn't you just subtract x from both sides and subtract 4 from both sides? Actually, no, we don't want to do that. Don't subtract 4. We're solving for x. So we want to subtract 2 from both sides and put the variables on one side. So on the left, we would have 9x equals 2. So our final answer would be x is equal to 2/9. Well, can you have a 2/9 here?
Yes.
Can you have, we don't need that one. Can you have a 2/9 there?
Yep.
Sure, why not? So that's a good answer. All right, so just to sum it up here, I actually posted this assignment, but I didn't give an assignment date, but I will now that I finished. It'll be due Friday before spring break. That's this week. When you have one logarithm, you're going to use the definition of a logarithm and write it in exponential form. If you can equate two logarithms, you're going to use that property that I just gave, where you can eliminate the logs when you equate them. But remember, if you're going to use either one, you can't have a bunch of fluff hanging around. You've got to make them look like the forms. Okay? All right, well, listen, I hope you guys have a great day. Anybody want to ask me about anything? Questions?
Does it matter which side you put the when you cross multiply? Does it matter which side you put it on?
No, doesn't matter. You could have put x plus 2 over here and 2 times 5x plus 1. It does not matter. On this one, though, on this one, you remember when you have a quadratic, you have to set it equal to 0 and try to factor. Over here, this was linear. So remember from algebra 1, you put the x's on one side and the numbers on another side? Yeah. All right, you guys have a great day, okay? Have a great day. Talk to you later.